Hello and welcome to the Daily Space. I'm your host, Dr. Pamela Gay, and I am here to put science in your brain. Beth Johnson is off today, taking a well-deserved day of rest, and she will be back on Thursday. On April 19th at 0734 UTC, which was the middle of the night for us here in North America and around noon, where perseverance and ingenuity are located on Mars. Well, at that strange hour, NASA's Mars helicopter Ingenuity successfully performed the first powered flight from the surface of another world. It was a relatively short flight, only to 3 meters in altitude with a flight time of just over 39 seconds, but it made history. Let's take a look. While little Ingenuity's first flight wasn't the stuff of too many oohs and ahs, we know great things are coming. And while we wait for it to do more interesting things, we have another mission that decided to overcompensate. NASA has released images of the site on the asteroid Bennu where the OSIRIS-REx mission punched the asteroid. I have to say, every time I read or hear about what happened, new details make the story even more interesting. The mission's intention was to boop the asteroid with the mission sample arm, blast the surface with the air canister to launch the material into the sample container, and then fly away after just a couple of seconds. This is still what is shown in released animations, but what actually happened caused a massive stirring up of material in the crater and flinging of it to fairly significant distances. As we now know, the mission stabbed its arm into the surface, blasted the air canister while under the surface, and would have kept plunging into the asteroid if it hadn't used reverse thrusters to escape after its arm was already half a meter into the asteroid. To give you a sense of scale, this crater, the darker region in the center of the image that is smoother, it's roughly the size of a large parking spot. And the mission's intended boop stirred up this entire region. This was not expected. It was supposed to be small and gentle. We punched an asteroid, people. We punched an asteroid. Spacecraft often make super surprising discoveries. They don't usually crash and boop and such to asteroids. We build them to accomplish one set of science objectives, and we give them what we hope is enough flexibility to handle any random situations or discoveries that are made along the way. It's this flexibility that made OSIRIS-REx such a great mission. And we hope to see the OSIRIS-REx mission be followed by Lucy that goes out to explore distant asteroids and hopefully make some less traumatic but equally scientifically awesome discoveries. For this mission, however, the random discoveries have actually started before the mission was even launched. Lucy is scheduled to launch in October and will do flybys of Trojan asteroids, those chunks of rock that share an orbit with Jupiter that are gravitationally clumped up ahead and behind the planet in its orbit around the Sun. This mission is being put on a very elliptical orbit that will allow it to visit first the leading Trojans and then on its next orbit to visit the lagging Trojans. The orbit was specifically designed to allow the mission to do close flybys of 7 known objects, and it's expected that newly discovered objects may be added over the course of the mission. In January 2020, though, it was realized one of those planned 7 objects actually had a moon, a little tiny one. And so we added a new object before it even took off. And continued observations using the ground-based asteroid terrestrial impact last alert system, or ATLAS, based in Hawaii, researchers have found that these systems don't just have binary asteroids we didn't know about, but they also have different sets of characteristics we didn't know about. In this case, they have different average shapes, with the leading asteroids tending to be more elongated and smaller. According to research on Archive led by Andrew McNeil, the leading cloud also has more objects in it. And this combination of facts seems to indicate that with more objects to collide, more collisions have indeed taken place, each one reshaping the asteroids involved. When it launches later this year, Lucy is expected to take off on a long, slow journey that will bring it to the leading cloud in 2027, and it will then visit the trailing cloud of Trojans in 2033. Expect more discoveries in the years before the encounters as observers here work to make sure Lucy doesn't encounter any surprises out there. Now, not all of today's news comes from within our solar system. After the break, we'll be back to discuss fast radio bursts and other things that flicker and flare in the night. Stay tuned. One of our regular topics, fast radio bursts, has a new advancement. First discovered in 2007, these are literally momentary flashes of energy that reach Earth in the radio portion of the electromagnetic spectrum. Often, there will be just a single flash from a place in the sky that we can't link to a single star or other object. Other times, we see recurring flashes. To try and get a better sense of what might be happening, joint observations were made with the CHIME radio telescope in British Columbia, Canada, and LOFAR in the northern Netherlands. CHIME operates at 500 to 800 megahertz, while LOFAR sees at longer wavelengths from 10 to 240 megahertz, which extends to either side of the FM radio band. Working together, they observed recurring fast radio burst 2018-09-16b. They discovered that the fast radio bursts emitted energy at longer wavelengths, and those lower energy photons arrived at LOFAR 3 days after the higher energy light was seen by CHIME. According to study co-author Danielle McKelly, this systematic delay rules out explanations for the periodic activity that do not allow for the frequency dependence and thus brings us a few steps closer to understanding the origin of these mysterious bursts. This work appears in the astrophysical journal Letters and was led by Ziggy Polanis. While we don't know what fast radio bursts are, there are hints they are some kind of a neutron star that has massive magnetic fields that periodically rearrange themselves and let off a massive burst of energy. We see other objects, including our own sun with its own solar flares, exhibiting this kind of energetic magnetic field-related behavior. If fast radio bursts do come from neutron stars, this means that some of the smallest glowing objects in the sky are also responsible for some of the most energetic crackles we detect. Neutron stars are the dead remnants of massive stars that aren't massive enough to explode as supernova, but are massive enough that when they can no longer support themselves through energy production via fusion, they will collapse down and crush their atoms into exotic forms of matter. Neutron stars are roughly the size of Manhattan Island and can contain a bit more than 2 times the sun's mass in stuff. Theories suggest that the outer skin can be fairly normal matter, but inside the dead star, pressure forces protons and electrons to combine into a dense degenerate gas of neutrons. What we didn't know was if the superdense core was just neutrons or some more compact form of matter, like a quark soup. New research from the International Space Station's NICER X-ray telescope looks at one of the largest mass neutron stars out there, pulsar J0740 plus 6620. It also looks at the average mass J0030 plus 0451 as a comparison object. Early results indicate that the higher mass pulsar is bigger than predicted by a quark soup center theory for its structure. This is a theory where neutrons can no longer stay neutrons and instead break apart into the constituent quarks that make up all the standard electrons, neutrons, protons that we deal with. Now, while it's bigger than predicted by the quark soup center theories, it's also smaller than predicted by theories with just neutrons and protons making up the structure of the star. This was not expected and hints at new states of matter. According to team lead Cole Miller, NICER is not only rewriting the textbooks on neutron stars, but also revolutionizing our confidence in our measurements of objects that are both very distant and very small. According to study co-author Anna Watts, our new measurements of J0740 show that even though it's almost 50% more massive than J0030, it's essentially the same size. This challenges some of the more squeezable models of neutron star cores, including versions where the interior is just a sea of quarks. J0740's size and mass also pose problems for some less squeezable models, containing only neutrons and protons. Understanding what is inside neutron stars may help us understand black holes and allow us to get at new fundamental physics that tells us the story of the earliest moments of our universe. Neutron stars and lower mass white dwarf stars are so dense that they can get closer to any potential companion stars than is healthy for those companion stars. They will literally strip material off their companions. In some cases, that infalling material, when it gets dense enough, can explode in myriad different ways referred to as novae. Currently, 3 different novae are visible to small telescopes: V1710 Scorpii, V6595 Sagittarius, and V1405 Cassiopeia. All 3 systems appear to be classical novae. These are systems made up of a white dwarf star, an object about the size of the moon with the mass of the sun, and a lower mass companion star that is being stripped of material. There is an excellent article on how to find these objects with a small telescope in skyandtelescope.org, and we will link to that article on dailyspace.com. If you're a morning person and you've got a telescope, and you're in the Northern Hemisphere, these objects are out there waiting for you. And in fact, 2 of them are fairly close to the equator, so even if you're in the Southern Hemisphere, give the article a look. You might be lucky. After a quick break, we'll be back to talk star formation. Stay tuned. One of the most stunning regions in the sky for amateur astronomers to observe is the Orion star-forming region. From the famous M42 nebula in the Sword to the Horsehead Nebula, to cloud after cloud of glowing nebulosity and knots of star formation. This region of the sky is a complex of star formation that allows researchers to see all the short-lived stages of how gas becomes stars. As we've said before, and will say again, we don't fully understand star and planet formation. But we understand the broadest brushstrokes. At its initial stages, a giant molecular cloud will collapse and fragment into dense cores that will, over time, continue collapsing into a spinning disk with a protostar in its center. These systems can draw in more or less material, growing more or less depending on what they pull in. Over what time this occurs, well, that's been a bit of a mystery, and it was suspected that perhaps large stars were able to continue growing by drawing material from around them, and possibly from neighbors forming around them. In new observations taken with the National Optical Astronomy of Japan's Naboyama 45 radio telescope, well, they find that the competition for resources occurs at the earliest stages of star formation, with dense cores already stealing material to reach a size that reflects their final mass before the stars really look like stars. This team looked at regions of star formation both at the earliest dense cores of collapsing material stage and at the newly formed stage of stars. And they found that the distribution of masses in these two different kinds of systems, these two different ages of systems, are the same. Prior to these results, it was thought that stars either formed through a competitive accretion model, where all stars start with roughly the same size dense core and over time grow more or less successfully, or that stars grow through a core collapse model where different sized dense cores formed and led to different sized stars. These results indicate that, at least for the Orion Nebula, the core collapse model appears right. These observations are now being expanded to other star-forming regions to see if this is a universal result or if, as so often happens, the universe is doing the same thing in multiple ways in different places. What I love about this research is it is allowing us to really build a movie of star formation over time. We see the dense cores, we see the first glimmers of a star forming surrounded by a cocoon of a material. These are stellar proplyds. We see the stars lighting up and blowing away their surrounding gas. Stage by stage, somewhere in the Orion Nebula, we can catch it all. We just need to look in all the wavelengths of light and put it all together to see if we can figure out the details of what is happening. After the break, we'll be back to look at our own planet Earth. Stay tuned. We talk a lot on this show about climate change, especially what we are undergoing now. The activities of humans have definitely had an impact on the current climate situation. But nature likes to have a hand in everything as well. And we're still learning just how some of the larger processes, like mountain building, are affected by climate in the past and how they are being affected by climate change today. In a recent paper in the journal Tectonics, researchers theorized that a feedback loop existed between tectonic deformation, the changing of shape of the surface, and the climate about 13 to 7 million years ago in the North Patagonian Andes of South America. The team conducted field observations focusing on an area called the Foreland Basin, which is in the east of the Andes and is basically the area behind the mountains that gets pushed back and folded up as the mountains rise. The Andes began forming when the Nazca Plate began to subduct to plunge under the South American Plate. We talked a few episodes ago about how volcanic arcs form, and the Andes are essentially a volcanic arc formed on land instead of as islands. As these volcanoes grew, they deformed that foreland basin. The largest period of deformation occurred in that 13 to 7 million years ago window and then started to decrease. At that point, glaciation began in the mountains themselves. Now, with the glaciers eroding away through warmer temps and increased rainfall, and not just due to the climate change, but extending back a couple million years, the foreland basin deformation has stopped, and fault activity in the mountains has increased. Researchers now have the numbers to confidently say that climate change can actually affect mountain building processes, and not only the other way around. Friendly reminder that the world is bigger than we sometimes realize and also sometimes smaller. And it's all tied together. Speaking of the Andes, a recent paper published in the journal Latin American Antiquity examines how structures in the ancient city of Carrell in Peru were oriented based on astronomy. The city itself, long since abandoned, dates back to around 3000 before the Common Era. And the society that lived there was the Supa culture, named for the river on which the city was built. And while much of that city is oriented parallel to the river, as one would expect from a predominantly agricultural society, several of the large and clearly important pyramidal buildings have an orientation that aligns with the full moon and the June solstice. First author Cesar Gonzalez Garcia explains, "It is noteworthy that these orientations can be related to the precipitation cycles on the Andean summits, with the consequential beneficial flooding of the river, and thus with the agricultural cycles. That time also coincided with the end of the fishing season taking place over a wide area of the nearby coast." Co-author Juan Antonio Belmonte notes, "The results of the research in the position and the orientation of the main buildings show that the presence of the river Supi is the main determining influence on the orientation of the buildings, because although they are not seated directly at the river, they are systematically parallel to it is a curious phenomenon, convergent with what was occurring at the same time thousands of kilometers away in a valley on the Nile." These monuments from the Supi Valley culture from 5,000 years ago are now the first and therefore oldest examples of pre-Columbian American interactions between the landscape and the sky. And this is your daily reminder to look up and observe how astronomy influences your life. This has been The Daily Space.